Think about this. Some beautiful funda sitting here. I draw a number line and I have points P and Q here. Distance between these two is Q minus P. More generally, the sum 2 points in the number line, distance between them is modulus of m minus n. Why am I saying modulus of m minus n? I don't even need to know whether it is m here, n here, or n here and m here. Doesn't matter. 2 points in the number line. What is the distance between them? Modulus of p minus q, modulus of q minus p, modulus of m minus n. That idea is super powerful. So that idea is going to crack open this question brilliantly. Whenever you have modulus of x minus 1 plus modulus of x minus 4 plus modulus of x plus 3, all of that, then say, okay, there's a bunch of things involved here. I'm going to draw a nice number line. I have a modulus of x, so I'm going to put 0. I have modulus of x minus 1, I'm going to put 1. X minus 2, 2. X minus 4, 4. X minus 6, 6. X minus 10, so my diagram is looking ugly. So I'm going to erase everything, restart. I thought there was some x plus as well. I'm going to put 0 here. This 1, 2, 4, 6, and 10. Nice. F of x is modulus of x plus 2 times modulus of x minus 1 plus 2 plus modulus of x minus 2 plus modulus of x minus 4 plus modulus of x minus 6 plus 2 times modulus of x minus 10. Nice. And so, forget the 2 times part. Right. So, suppose x were here. X minus 0, x minus 1, x minus 2, x minus 4, x minus 6, x minus 10. I'm calculating all these distances. Suppose x were here. X minus 10, x minus 6, x minus 4, x minus 2, x minus 1, x minus 0. I'm adding all these distances. It's a 2 times. If I'm adding all of them, it is better to add from here. I don't have to think about x here. If I put x at 0, that will be better than putting x here. All these distances won't get added. First step. Likewise, beyond 10, I don't need to worry. I'll worry about 10. Right? But if I worry about 10, 10 to 6, 10 to 4, 10 to 2, 10 to 1, 10 to 0, instead of that, if I had x in the middle, to 10 to 0, to 6 to 1, to 4 to 2, I can count like that. I can already intuitively sense that it will be better if I put x in the middle, not on one side. And so that's a beautiful idea. And digging deeper, if I put x here, this is modulus of x minus 2, this is modulus of x minus 4. Add these two distances, that's 2. Wherever x is in between, doesn't matter. Likewise, x minus 0 is this distance. X minus 1, I'm putting x here. X minus 1 is this distance. X minus 6 is this distance. X minus 10 is this distance. If I put x here, I'll have x minus 4, x minus 6, x minus 10, x minus 2. Just depending on where x moves, I'll have the numbers changing a little bit. Right? I can sense that if x is more to the center, then I can split these terms. So if I put x's here, then each of these keeps adding up. Go x inside, then x to 1 and x to 0 gets shortened. If I put x at 0, then each of these distances gets added. If I put x here, all of these lengths become shortened. X to 0 also will be non-zero, but it's going to get offset. I can sense that x is somewhere in between. If not in between 2 and 4, it is in between 1 and 10. Somewhere in between. What I'm saying, if it is in between, then this modulus of x minus 2 and modulus of x minus 4, these two add up to 2. Likewise, modulus of x minus 1 and x minus 10, x minus 1 and x minus 10, these two add up to 9. So let's pair them up. We'll use our fact that we have color coding available. I'm pairing these two. Then what will we pair? We pair up modulus of x and modulus of x minus 6. Modulus of x should go all the way till here. And then we pair up modulus of x minus 1 and x minus 10. If you pair them up like this, modulus of x minus 2 plus modulus of x minus 4 is 2. This plus this is 6. This plus this is 9. Why? The distance between 1 to 10, if x is in between anywhere here, is adding up to 9. This distance plus that distance adds up to 9. This distance plus this distance adds up to 2. This distance plus this distance adds up to 6. Or effectively, we have 2, we have 6, we have 9 into 2. 9 into 2 is 18, plus 6 is 24, plus 2 is 26. That is the minimum. So this whole question becomes far better if we understand the distance between x and y on the number line is modulus of x minus y. So we're doing modulus of x minus 2 plus modulus of x minus 4. Distance to 2, distance to 4. Best or minimum when the number is between 2 and 4. Locate a number between 2 and 4. I can pair 2 and 4. I can pair 0 and 6. I can pair 1 and 10. Why am I pairing 1 and 10? Because that distance is getting doubled. X minus 1 and x minus 10 coming twice over. 9 into 2, 18, plus 6 plus 2. 18 plus 6, 24 plus 2, 26. Just to drive home that funda, that modulus of P minus Q is the distance between P and Q. That idea is super powerful. So grab onto that idea, it becomes far simpler. Best wishes.